Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the molecular orbital energy level diagram for He2 molecule and C2 molecule, students. Okay. So first of all, He2 molecule. These two molecules belongs to up to 14 electron, students. Okay, Nama. So in last classes, in previous videos, I discussed hydrogen molecule, H2 molecule, Nana, and Li2 molecule also. Please, once you go through that, then you can easily understand, students, that how to draw the tape, how to draw the diagram, how to write electronic configuration of molecule, how to find bond order, magnetic nature, everything I discussed with students. In this section, I am going to discuss about He2 molecule and C2 molecule. First of all, He2 molecule we are discussing. He2 molecule. So coming to the He2 molecule, students, He2 molecule, first I am taking the helium atom, atomic number is 1, sorry, helium atomic number is 2, students. What is electronic configuration? 1s2. That means how many electrons there, students? Atomic number 2 means 2 electrons are there. So here in He2 molecule, 2 helium atoms are present. So here this is one helium atom, another helium atom, atomic number is 2, electronic configuration 1s2. It is also having 2 electrons. Total how many electrons, students? 4 electrons it is having. That means it is up to 14 electrons. So up to 14 electrons, what is electronic configuration, students? We have to follow up to 14 electrons electronic configuration. So what is up to 14 electrons, students? Up to 14 electrons electronic configuration. What is energy increasing order? Energy increasing order. Okay, in last classes I gave you, students, up to 14 electrons, after 14 electrons, 2 energy increasing orders I gave you. I am writing here up to 14 electrons. Sigma 1s less than, sigma star 1s less than, sigma 2s less than, sigma star 2s less than, pi 2py equal to pi 2pz less than, sigma 2px less than, pi star 2py, pi star 2pz less than, sigma star 2px. Clear? So this is the energy increasing order. Here we have helium atom only 1s. So that's a only one diagram will get up to 1s. Okay, now I'm taking the helium molecule diagram, Nana. See here, He2 molecule diagram. 1s only electronic configuration 1 kada, so one diagram only will get, students. So that is, this is 1s. This is molecular orbital energy level diagram for He2 molecule, students. He2 molecule, this is one helium atom, this is helium atom, this is another helium atom, atomic orbital. What is this, students? Atomic orbital. This is also atomic orbital. This is molecular orbital. Clear? Molecular orbital. What is this molecular orbital? Sigma 1s. This is sigma 1s. This is molecular orbital anti-bonding. Here star is there means it is anti-bonding molecular orbital. So it is sigma star 1s. Clear? This is sigma 1s. This is sigma star 1s. Understood, Amma? So these are molecular orbitals. This is atomic orbitals. These two are atomic. These two are molecular orbitals. Okay, fine. Now see, students, here in helium atom electronic configuration is 1s. So this is the 1s atomic orbital. This is 1s. This is also 1s. So first helium atom 1s. How many electrons are there, students? 2 electrons there. So take here 2 electrons. Another helium atom also having electronic configuration 1s. How many electrons? 2 electrons are there. So take here 2 electrons. Total 4 electrons. So these 4 electrons, here 2 electrons will come, here 2 electrons. So total molecular orbitals all are paired here. This is bonding molecular orbital. This is anti-bonding molecular orbital, students. All are paired. Now we have to find the bond order. First we have to write the electronic configuration. Now tell me students, what is the electronic configuration of He2 molecule students? He2 molecule. What is electronic configuration? Sigma 1s. In sigma, this is the electron energy. In this order only you have to write. Sigma 1s, how many electrons there? 2 electrons. Next, sigma star 1s, how many electrons students? Sigma star 1s also 2 electrons there. This is the electronic configuration of He2 molecule. Clear? Sigma 1s2, sigma star 1s2. Here you no need to write here less than. Are you clear? So this is here energy increasing order is in this order. This is energy increasing order. That means sigma 1s less than sigma star 1s. Like this. Okay. Down to up then. Okay. So this is energy increasing order completed. Now we have to find the bond order. So what is the bond order students? Formula half into NB minus NA. Half into NB minus NA. Now tell me students, how many NB is nothing but what students? NB is equal to number of bonding electrons. Clear? Number of bonding electrons. Number of bonding electrons, so NB. How many bonding electrons? This is bonding molecular orbital. This is anti-bonding star there na, anti-bonding molecular orbital. So in bonding molecular orbital, how many electrons? That is equal to NB. So how many electrons there? 2 electrons. Na, what is Na students? Number of anti-bonding electrons. Okay, number of anti-bonding electrons. How many are there in anti-bonding? 2 electrons are there. Are you clear? So 2 electrons students. Now NB minus Na means how much Nana? 2 minus 2. NB also 2, Na also 2. So 2 minus 2 is nothing but 0. So you will get the answer 0. That means bond order value 0. Okay, bond order is equal to 0 students. So here you tell me students, this molecule is existing. This molecule He2 molecule is stable or not? How can you say? I told you already in the previous section students, if NB is greater than Na, molecule is stable. Okay, if NB is less than Na, molecule is unstable students, unstable. Now tell me students, NB here, NB equal to Na happened. Are you clear? NB is less than or equal to Na. So see here, NB equal to Na, both are same value, 2 electrons, 2 electrons. So that's why the molecule is unstable. That means He2 molecule is not existing. Are you clear? Because helium atom, it is a noble gas element. It is existing in the atomic state. It is in the atomic state only it is stable. So in the molecular state it is unstable. Are you clear Nana? So He2 molecule is unstable. Clear this one, and does not exist. Clear? He2 molecule is what students? He2 molecule is unstable and does not exist. Clear? Does not exist. Understood amma? So this is about the He2 molecule. Understood amma? Now we are going to discuss about the C2 molecule Nana. See here, C2 molecule. Now I am taking C2 molecule. C2 molecule. Now tell me students, carbon atomic number how much? Carbon atomic number is 6. Correct? 1s2, 2s2, 2p2. 1s2, 2s2, 2p2 electronic configuration. One more carbon atom also 6 atomic number. Electronic configuration 1s2, 2s2, 2p2. How many electrons there students? Atomic number 6 is nothing but 6 electrons. Here also 6 electrons, because in C2 molecule 2 carbon atoms are there. That's why I am taking here 2 carbons. Total how many electrons? 12 electrons. So this is also up to 14 electrons. Energy increasing order you have to write Nana. Up to 14 electrons. So that means here already I told you up to 14 electrons. This is the energy increasing order. In this order only you have to fill the electrons. Okay, now I am writing. See here 1s there, 2s here in the carbon students, 1s, 2s, 2p is there. So that means up to 2p you have to write. That means here see in energy increasing order 1s, 2s, 2p, 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 2p is there. So that means total energy increasing order in this order 2p, up to 2p is there. So that's why we will get the 3 diagrams students here. See here, first I am taking from See here, from down to up I will write, amma. Sigma 1s first, next sigma star 1s, sigma 2s, sigma star 2s, pi 2py, pi 2pj. According to this order only I am taking the diagram. Now see here, C2 molecule. So first from down to up I will take, nana. Now see here, this is 1s, this is 1s. Okay, now 2s, this is 2s. Okay, next 1s over 2s over 2p is there. So 2p I'm taking like this. Here in 2p, nana, here sigma 1s, sigma star 1s, 2s, sigma star 2s. Now here pi 2py, pi 2pz. So I am taking here two orbitals. Here pi sigma 2ps, only one orbital. And after that again here two boxes, here one box. Now here join like this. Three orbitals. Okay, this is the diagram, students. See here, this here how to write here. This is which atom? First of all, carbon atom. This is one carbon atom, atomic orbitals 1s, 2s, 2p. Clear? This is first carbon atom, this is second carbon atom. This carbon atom, okay na, 1s, this is 1s, this is 2s, this is 2p. 1s, 2s, 2p, 1s, 2s, 2p. Clear? And another carbon atom also having 1s, 2s, 2p. So this is 1s, this is 2s, this is 2p. Now I'm filling the electrons. See here, 1s, how many electrons there, students? First I'm taking the first carbon atom. 1s 2 electrons, 2s 2 electrons, 2p also 2 electrons. So in 1s 2 electrons, 2s 2 electrons, next in 2p 2 electrons there, 1 2. Clear? Understanding? So like this you have to take. Now here also as it is, another carbon atom also having 1s 2 electrons, 2s 2 electrons, 2p 2 electrons. So here also 2 electrons, 2 electrons, here 2 electrons. Clear? Arthaithamma? So this is about the diagram. Now here see, students, energy increasing order. In this order here, energy increasing order, that means from down to up. Now here see, nana, this one here order I told you na. Once again here I will write, otherwise you will get confusion. See here, what is the energy, what is energy increasing order, nana? Energy increasing order. See here, sigma 1s less than sigma star 1s less than sigma 2s less than sigma star 2s less than pi 2py. Next, pi 2pz less than sigma 2px less than pi star 2py, pi star 2pz less than sigma star 2px. This is the energy increasing order up to 14 electrons. Clear? Now in this order only I am writing from down to up, nana. See here, this is sigma 1s, this is sigma 1s. Next which one? Sigma star 1s, this is sigma star 1s. Next sigma 2s, this is sigma 2s. This one sigma star 2s. Next pi 2py, pi 2pz. So this is pi 2py, this is pi 2pz. Next this one is sigma 2px. Clear? Now these two orbitals, degenerate orbitals, pi star 2py, pi star 2pz, both are having the same energy, pi star 2py, pi star 2pz, and last one is sigma star 2px. Clear? This order only, just down to up I wrote. This is sigma 1s, sigma star 1s, sigma 2s. Clear? Next sigma star 2s, pi 2py, pi 2pz, sigma 2px. Next pi star 2py, pi star 2pz. This is sigma star 2px. Clear, Amma? Now see, students. So we know that these are all atomic orbitals. Clear? These are all atomic orbitals. Atomic orbitals. These atomic orbitals, these are also atomic orbitals. Now middle one, these orbitals there na, this middle, okay na, these orbitals are molecular orbitals. Which orbitals, students? Molecular orbitals. Okay, now fill the electrons. Here 2, here 2, total 4. So here take 2, here take 2, total 4 balanced. Now coming to here 2, here 2, total 4 electrons. So here also 2, 2, 4 balanced. Now here 2 electrons, here 2 electrons, total 4 electrons are there. So that 4 electrons here, 1, 2, 3, 4 balanced. Now here these are all vacant orbitals. Here there is no electrons here because 1, 2, 3, 4, total 4 electrons. So here only have to fill the electrons. Understood, Amma? So this is the diagram. Now we have to find the first you should write the electronic configuration. Now tell me, students, what is the electronic configuration of C2 molecule? From down to up you have to tell me. Okay, from down to up, sigma 1s, how many electrons, Nana? In this order only we are writing, in this order only. Clear? In this order only we are writing, Nana. See here, sigma 1s. So first I am writing sigma 1s. How many electrons? 2 are there. Next, sigma star 1s. How many electrons? 2 electrons. Next, sigma 2s. How many electrons? 2 electrons. Next, sigma star 2s. How many electrons? 2 there. Next, pi 2py. How many are there? 2 there. Equal to pi star pi 2pz 2. Clear? In 2py 2 electrons, in 2pz also 2 electrons there. So this is the electronic configuration. This sigma 2ps in these orbitals no electrons now. So this no need to write. Up to here only you have to write the electronic configuration. Clear? Now after this, after electronic configuration, you have to find the bond order. Now coming to the bond order, students, formula half into Nb minus Na. So tell me, students, first of all, what is Nb here? How many bonding electrons are there? Here this down. In this diagram, down is bonding, this is bonding, this is bonding. What are the stars are there? All are anti-bonding molecular orbitals. Clear? Now Nb is equal to bonding electrons, Na is number of anti-bonding electrons. So number of bonding electrons, how many? Here 2, here 2, here 2, here 2. Total 2, 4, 6, 8. Clear? So how to find, students? Number of bonding electrons 8. Number of anti-bonding electrons here 2, here 2. Here there is no anti-bonding electrons. Clear this one? So only anti-bonding electrons 4 there. Sigma star here 2, here 2, total 4. Understood, Amma? So bonding electrons 2, 2, 4, 4, 6, 8. Number of anti-bonding electrons here 2, here 2, total 4 only. Are you clear? So half into 8 minus 4 means half into 4. Then how much, students? So total 2. That means bond order is 2. Bond order is 2 means what we can say, students? In between, in C2 molecule, in between the two carbon atoms, Nana, in between the carbon atoms, which bond is existing? Double bond is existing. Bond order 2 means double bond. Bond order 1 means single bond. Bond order 3 means triple bond, Nana. So here bond order 2 now. So that's a double bond is existing. Are you clear? So this is the bond order. Now we have to find the magnetic nature. So coming to the magnetic nature, students, magnetic nature. Now tell me, students, magnetic nature. The molecular orbitals, if suppose paired. So what here what I told you, students, molecular orbitals paired means diamagnetic. Clear? Diamagnetic. If molecular orbitals are unpaired, that is paramagnetic, students. Clear? Now see here, paramagnetic. Now magnetic nature, tell me, these are all molecular orbitals. This is paired, 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 paired. Any unpaired electrons are there? No. All are paired na. So that's why, what is the magnetic nature? Diamagnetic. So that's a C2 molecule is which nature, students? Magnetic in nature. Clear? Diamagnetic in nature. Understood, Amma? So this is about the molecular orbital energy level diagram for C2 molecule. Understanding? So this is He2 molecule, C2 molecule, both up to 14 electrons only. Understood, Amma? So this is about the molecular orbital energy level diagram for He2 molecule and C2 molecule. Okay, I hope you understood. I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, students.